Hello, friends. Let's do some probability. Number 15 starts with what you would call the fundamental counting principle. We want to know the number of possible outcomes in this sample space. And so a button is pressed and the computer program spits out an odd number that's greater than 1, less than 9. We press the button 2 times. Well, how many different possibilities are there the first time we press it? Okay, greater than 1, so that would be 3, 5, or 7. So there's 1, 2, there's 3 options. And then we're going to press it again where there's 3 more options the second time we press it. If you multiply those together, you find the total number of possible outcomes in the sample space. So there's 9 different ways that could go. 3, 5, 3, 7, 3, 3. That's 3 ways. 5, 3, 5, 5, 5, 7. That's 6. 7, 3, 7, 5, 7, 7. That's 9. Let's check that. See if they're saying it, doing it the same way I'm doing it. 50. Let's try 54. A basket contains 6 apples and 6 peaches. You randomly select one piece of fruit and eat it. Then you randomly select another piece of fruit. Both pieces of fruit are apples. Hold on a second. Wow. Scrolled up to the wrong spot. Let's talk about the pizza stand first. I was like, this is a more complicated problem. As it's late, I'm losing my mind. It's also late in the year. A pizza stand offers both hand-tossed and pan pizza. Customers can add any combination of 8 available toppings. Okay, so here's what we want to do. We want to think about all the things. So there's a lot of choices that are being made here. So hand tossed or pan, that would be 2 choices. Now let's think of the other choices as yes or no choices to all 8 toppings. This is kind of a tough one. So let's say the first topping is cheese. It's a lot simpler if instead of thinking of all the ways that you could multiply out these toppings to just say cheese, yes or no. That's 2 choices. Pepperoni, yes or no. That's 2 choices. Sausage, yes or no. 2 choices. Pineapple, I don't know, whatever, blah, blah, blah. All the other ones. We're going to just multiply those. So this is actually 2 to the 9th power. That's the number of choices we have to make, or the number of possible combinations of pizza we could make. 512. I'm going to go down to the bottom and check 51. 512. Yay. Okay, let me get back to you, basket of peaches. First, we're going to talk about boxes of chocolates. Life is like a box of chocolates. It has 5 milk chocolates and 8 dark chocolates. That means I'm going to eat 5 out of 13 of these pieces and put the other ones in the trash. You, however, randomly pick a chocolate and eat it. And then you randomly pick another piece. What's the probability that both pieces you pick are milk chocolate? Okay, this is an example of dependent events. Okay. Dependent because if I pick a milk chocolate out the first time, which I have a 5 out of 13 chance of doing so, if I succeed, the next one, my probability on the next choice depends on that. So there's 1 less milk chocolate piece in there, right? So I only have 4 options, but there's also only 12 pieces of chocolate in there altogether, 12. So I can multiply 5 over 13 times 4 over 12, which is just no. 1/3. Oh my goodness, I'm struggling. There is a 5 out of 39 chance that happens, that I get both milk chocolate. Another way of thinking of it is favorable outcomes over possible outcomes. So this is, again, the fundamental counting principle, but you're counting two separate things. Favorable things you're counting. So there's 5 milk chocolates. Those are my favorable options. And then if I get one, the next time there's 4. So there's 20 possible ways that I could choose those chocolates and be a happy person. And then possible ways, there's 13 chocolates total I can choose from. And then the next time there's one less, there's 12 because I ate one. So there's a whole realm of possibilities there. Fundamental counting principle, but you do it twice and now all of a sudden you have a probability. All right, back to apples and peaches. We're going to take one out and eat it. And then we're going to take another one out. We want to know what's the probability that both of the ones we get are apples. The first choice is pretty simple. There's 6 apples, there's 12 fruits. That would be 6 out of 12 or 1/2. There is a 50% chance that I will get an apple on the first time. The next time there's a little less than a 50% chance because I already ate one of the apples. Now there would be 5 apples and 11 total fruits in the basket for a 5 out of 22 chance of me getting 2 apples. Now let's do these 2 and we'll be done. All right, we are now told that events A and B are independent. What does independent mean? It means that they do not affect one another. It's like drawing the ace of spades out of a deck of cards and then going over and picking up a quarter and flipping heads. You aren't more likely to flip heads on a coin just because you got the ace of spades, or less likely one way or another. So that's what we're talking about here. It tells us the probability that B happens is 7 out of 20. The probability that A happens after B happens is 1 out of 4. So what's the probability that A is going to happen? Well, they just told us that they're independent, which means this thing, which means given B, given that B happens, there's a 1 in 4 chance that A happens. Well, who cares if B happens because B and A are independent of one another. So there's just a 1 in 4 chance that A is going to happen, whether B has happened or not. This is like, I put it on here and it seems silly, but this is the way we approach probability in the real world, is that we think, well, I've already beat the odds, so maybe we start to think I'm less likely to beat the odds next time, or I'm more likely to beat the odds because I've already done it. If they're independent events, like just because I flipped heads on a coin doesn't mean I'm more likely to pick it up and flip tails the next time. It's still a 50-50 chance. So there's that. All right, find the missing probability. This says that the probability of A is 3/10. The probability of A and B happening, so A happens and then B happens, is 9 out of 50. What is the probability of B given A? All right, well, I can find the probability of B. If you want to know the probability of A and B, that is just equal to the probability of A times the probability of B. B given A. So 3 out of 10 had to be multiplied by the probability of B happening to get 9 out of 50. So all I have to do is divide by 3/10, divide by 3/10, and I get that the probability of B is equal to 3/5. Is that right? 3/5? I think that's right. If it is, I'm going to celebrate and stop the video. Yay! Good luck studying for your test. Ask me any questions you may have. I'll be happy to answer them.